So in this problem, it's given that the sum of three numbers that are in AP is 21. Also, the product of the first term and the third term exceeds the second term by 6. So using these facts, we need to obtain the value of the three numbers. So let's begin. So what we'll consider, let's say, the first term, let it be represented by the letter A in lower case. Then we have the common difference. Because they are in AP, we also have to specify the common difference. So let's say we are representing it by the letter D in lower case. But what we will do here, even though I have mentioned here that we are considering A as the first term, but the three numbers that are in AP, what we'll do, we'll say that let A minus D followed by A and A plus D, these are the three numbers that are in arithmetic progression such that their sum is 21. Now that means that A minus D, which is the term preceding A, that this will be considered as the first term. Anyways, let's now begin. It's given here that the sum is given by 21. So we have A minus D added to A plus D. So this value is equals to 21. And the reason why I have chosen A minus D instead of choosing A as the first term, because this negative D and positive D cancels out immediately, leaving us with 3A equals to 21. And we can immediately find out the value of 3. So 3A value will be equals to 7. Now that we have the value of our first term A, we will use the second fact as given here, the product of the first term. That means if we take the product of the first term and the third term or the last term, that this is going to exceed the second term, which is A, by 6. Right? So we have A minus D times A plus D, so that's A squared minus D squared. This value is equals to A plus 6. And since we have already obtained the value of A, so we have 7 squared, which is 49, where 49 minus D squared equals to 7 plus 6. So that means we have 49 minus D squared, which is equals to the 7 plus 6, that's 13. And solving for D squared, we have D squared equals to 49 minus 13. And this will be equals to, so we have 36, which is going to give us the value D equals to plus or minus 6. That means we are going to have two cases. So the first case is when our A value is 7 and our D value is equals to 6. And in the next case, we have A value equals to 7 and D value is given by negative 6. Using this fact, we have to obtain the three numbers. So we consider A minus D, the next is A, and the third is A plus D. So let's find out their corresponding value whenever we have A given by 7 and 6. So we have 7 minus 6, so that's going to be positive 1. And the A value is 7, then we have A plus D, so that's going to be 13. Next we have A minus D, so 7 minus or minus 6 is going to give us 13 because we have 7 plus 6. Then we have positive 7 and followed by 7 plus minus 6, we'll simply get 1. So these are the numbers, so 1, 7 and 13, they are in AP. And we have the other number, 13, 7 and 1, they are also in AP. And in both the cases, we will see that the sum, which is 7 plus 13 is 20, 20 plus 1 is 21. So we have seen that the sum is equals to 21.